Jolly good.
Thank you. Sit in the front there.
Okay.
With the microphone.
All right. About there's a cable there.
Yeah, we can.
Okay.
Sit in the middle.
Like this here.
Facing you on.
Yeah. Okay. Okay.
Do you want the microphone?
Maybe.
Can you use this one?
Maybe. Oh, which one?
Oh no, actually.
Hello.
It's
all right. Okay.
I think we just draw a few curtains or something. The light's just going to get even.
Well, so what do you need to know? If you recall, I talked about quite a lot of things. I dismissed the carbon dioxide theory in about 2 minutes, and then talked about how the weather system works, and it involves a lot of electricity. I mentioned the seas, for example, and then I moved on to slide 52, which I think will be the subject for later on, which is about the future of where we're going and so forth. There was some stuff I did leave out, namely why the carbon dioxide theory never can work anyway. If someone wants to ask that as a question, I might answer it, but you might not want to. But, so anyway, I'll stop there as a kind of semi-intro to remind you of what I said and ask for questions.
Who wants to kick off? Where's Phil Francis? Phil? Floating about.
What should we invest in?
Sorry, what?
Yeah.
Truffles versus wine, and you were into.
I asked about truffles versus wine, and you told me to stick with the truffles.
Oh, I see. The ongoing future climate, which...
Oh, no. Piers is going. Well, we've got the other guys making us rich because we can now turn beer bottles into gold. Well, what are Piers' tips for investment in agriculture or whatever in becoming more under minimum?
Right. Well, under our view of the way the world weather is going, is it's going to get generally colder, and the jet stream will get more wild, and there will be more extreme, very extreme weather situations at certain points in time. The effect of this on European and American agriculture is that the growing seasons are shorter, which will cause problems. During the last Maunder minimum, or the Dalton minimum, because of the failure of agriculture in Germany, a lot of Germans moved to Spain, and that would happen. So again, so if you want to make some money investing, I would say invest in property in Spain. A thing to understand about the weather, that's how it's going to change in Spain, is the jet stream being drawn south also means that the track of low pressure systems generally is further south, and in the tail of a low pressure system that you get a wind from the north which will drag the surface currents further south. In other words, the Gulf Stream gets dragged south. Now, as it is under normal circumstances, the Gulf Stream has two prongs. One of them goes towards Spain and the other one goes towards Norway. The Norway one gets weaker and the Spain one gets stronger. So you get more rain in Spain, and even on the plain. And agriculture in Spain and North Africa improves. So, that is the place to go. Okay.
Oh, we'll retire to Spain.
Okay. Anybody else? Well, do you want to know the answers about the CO2, why it's complete nonsense?
Yeah.
Yeah, okay. Right, first of all, a pity I don't have, well I do have, yes I do have actually. Can I put up one of these pictures? I'll have to give you my USB and direct you to a certain number of slides. Here we are. While he's finding it, is there another question beforehand?
I've got one.
Yeah, please.
Where's the microphone?
Oh, where's the microphone? I don't know.
I need an assistant.
Yeah,
It's really taking.
I'm going to ask him to press things. There's another assistant needed to carry the mic.
Oh, okay.
or the mic can be a conch and you carry it around like you...
And self-organised.
Anyway, it's,
Yeah, but the last one who's got it keeps it, don't they, in order to fly,
Wait.
do you remember?
it's really, I want to ask Don Scott to comment. You talk about the jet stream moving south.
On average, yes.
Right. Now, to me, that's saying that the Birkeland Current is expanding outward,
Maybe.
you know. Because the Birkeland Current
Yeah,
is
yeah,
what's
yeah.
making,
Okay.
so I just wondered if Don wanted to comment
Okay,
on
that's
what would make
very good point.
the,
Excellent point.
what would make the Birkeland Current spread out. Is Don here?
Yeah, I mean, what would make the Birkeland Current spread out? It would get bigger, and what would make it bigger? More charge. And so the only thing I can think of, I mean, talk about being hit from the left-hand side here. I've never really thought about this, but I guess the only thing I could say is that generally, things in the cosmos vary. And so, do we have AC? No, there's no General Electric turbine generators out there. But in general, if there's variability, you can think of it as being a DC current plus some random signal. And so I guess the only thing I can think of is why it would expand is if you add more charge to it. And could that happen? Sure. Will it happen? I don't know. I don't think you can predict that.
Well, we do predict it.
Okay.
Yeah. Okay. No, I think that's a very good idea, and your question is very good. What my understanding is that
Walt's got a comment too.
it's a sun-earth connection, and those are changing. But before I go into that,
I just wanted to mention on that topic, in space, the Birkeland current diameter depends on the density of matter, so that if you get into a molecular cloud, what might be a very large Birkeland current will pinch down, and this is what you see in the atmosphere. You know, the lightning above clouds is very diffuse, and as you get beneath the clouds, it's a true arc, and it's very thin discharge. So it suggests that the sun's circuit is becoming more diffuse, and that might all be also be allied with the lack of, what would you say, lack of input to the Earth, so, and that would reflect in the larger Birkeland current.
excellent.
And could this,
I agree with that.
excuse me,
Yep.
could this process be cyclical? Did it happen sometime in the past? Yes?
Yes.
Would you know when approximately?
No, the things that can vary are like alphane waves, which can occur in the you can have wave effects in the Birkeland current, which can be cyclical, and the very fact that we're part of a circuit means that you will get resonance effects which will cause cyclical variations, and I think that's the origin of the solar cycle itself, but there can be longer term ones as well.
Thank you.
Yes. You see, I agree with that. In terms of our model, which is used to choose when we look in the past for similar sun-earth magnetic weather states as sometime in the future, we have our 60-year cycle, which is the beats between the magnetic cycle of the sun, 22 years, and the half cycle of the line of nodes of the moon, which is, this way of looking at it, is interrupting the solar wind. But of course, having said that, is another way of saying, well, it's interrupting and upsetting Birkeland currents. And, you know, that will give you these periods. And as I said, I had a conversation with somebody and they said, well, about 60 years ago,
Yeah. Sorry.
was it with you?
Maybe, yes.
Yeah, 60 years ago, a lot of these things happening now, in spread out time, you know, like 5 years, happened then. And you do have a definite 60-year cycle of extreme events. There is changes in the extremity of these extreme events and bigger cycles. And I think an important thing to point out in our view of things is the kind of feedback systems. Unfortunately, I haven't got my globe here, but if you imagine the globe, and you've got your jet stream going around, and when the jet stream's further south, the upper part is bigger, and that is the colder part. Now, standard meteorology says, oh yeah, world temperature, you just measure the surface and average and that gives you the temperature. Well, hang on, it's not actually as simple as that, because if I put, say, a white sheet on the top, and then I stretch out the white sheet, i.e. that could be ice, suddenly spread out, but the same amount of ice, then a standard meteorologist will measure the temperature, oh, it's got colder, when all I've done is just spread the ice around instead of putting it in a heap. So the way of measuring, well, something about the heat content of the world by average surface temperature is nonsense. It's a question of distribution. When the ice, for example, does get spread out, then of course you get more ice, then you will get more reflection, and you then get more cooling, and then the jet stream goes further south. So you have a feedback system, but standard meteorology doesn't deal with like the way I said. They talk about the heating first instead of the redistribution of surface phenomena, which will happen as the jet stream moves, and the jet stream moves under our rules, essentially. Shall I move on to the carbon dioxide thing?
Can I just ask?
Yeah, sure.
I understand, well, the connection with the weather and the sun is quite intuitive. And I was going to ask about the moon. You mentioned nodal points. Can you elaborate on that? Because it's, other than the moon physically blocking radiation from the sun, I wonder what else...
No, it's not radiation, it's getting in the way of the solar wind.
Solar wind, okay.
Here's this circle is the orbit of the Earth, approximate circle anyway, and my wallet, short of money, bias and forecast, is in the middle, that's the sun, and the Earth, well, okay, we'll make it the Earth now then. So then the orbit of the moon goes above and below the ecliptic, you see, and that orientation of that line rotates backwards. So where it crosses the ecliptic and interrupts the solar wind most will change, and that's where the 18.6 year signal is.
By the way, I'm showing this.
Is that what you meant? Was that your question?
Oh, okay.
Visually, so the lunar.
Okay.
Let me make a comment. You were talking about cycles. How do you predict the cycles? So this is a semi-heretical comment, because I'm assuming that the ice core records are valid, say, for at least the last 10,000 years.
Well, yes.
And if you look at those, the cycles are obvious.
Yeah, absolutely.
And so the Maunder minimum was a minimum in the ice core, and the medieval warm period was a peak in the ice core. And so from that, you can see that we're in for a 200-year decline just as rapidly as the last 200-year increase.
Absolutely.
Because the one thing about the spikes occur kind of, they're not exactly cyclical, but the one thing that's exact is the up and down are symmetric.
Okay, now we're going to do a bit of carbon dioxide. And I want you to listen carefully to this, because when you meet warmers, you can deal with them in 25 seconds when you know this. Where's he gone? We need to go to slide, hello Captain, go to slide,
is it the famous 52?
no, we're beyond 52. We're way beyond 52. 50, 60, 66, well, go right to the end, that's what it is. Go right to the end.
Oh, 88.
And work backwards, yes, that's right, 88, I've forgotten it was 88. So go 88, 87, 86, 85, 84. Right, perfect, right, okay, thank you. Now, this is the idea we're told that carbon dioxide sort of is in the air, and so then when you have some radiation from the surface, it goes to the CO2, and then the CO2 says, oh, okay, I'm warm, so I'm going to send some back. So then the model, their step model says, oh, look, now there's an extra heat coming into the surface, so it's got warmer. Right, now, there are some certain problems with this. I'm going to stand somebody in front of me. Who wants to be the Earth? You can be the Earth, right? There he is. You are the Earth. No, not too close, please. Just there, right? So he's standing there, and you're looking into space there. If you look straight to the window, right? He's radiating, you know. Okay. He's radiant, isn't he? Right. Okay. And he's got a certain input, and he's going out, and he's happy, right? So I'm a bit of carbon dioxide, and I'm going to stand in front of him. Okay, this is what they're saying. So what happens to me? I was at some temperature or other. I might have been cooler than him, might have been warmer. Suppose I'm cooler. I feel his heat. I warm up. What happens to my heat? I radiate there. I'm radiating at exactly the same rate as he's radiating to me. So he hasn't got warmer. Nothing has happened at all. Nothing has happened at all. Now, so this view is nonsense. So what is really going on? First of all, the assumption of their model is that what they call the radiative equilibrium at every level of the atmosphere. So they say, oh yeah, yes, this goes up there and then it all comes, meets something and all gets radiated. Actually, you see, I didn't have the radiation from him re-radiating. It warmed me up and I then radiated. Now, I could have done something else. I could have converted water vapour or liquid water into water vapour or something, right? So their model of radiative equilibrium at every level of the atmosphere is in fact complete nonsense. And the proper physicists in the Met Office and so on, if there are any, but there are some, okay, they know this is nonsense. Now in 2004, I was at a meeting in the Russian Academy of Sciences where the Met Office had come along to preach, to tell the Russians to sign the Kyoto Protocol, and some of us had been invited along by Putin's scientific advisor to upset them, and they were very upset that we were there, because they were told, they weren't told we were going to be there until they were at the airport. And Andrei Ilyanov, sorry this is a diversion, Andrei Ilyanov, Putin's advisor, phoned them up and said, oh by the way, Mr. Corbyn and Richard Lindzen and someone are going to be there. And they said, what? We're not coming then. And Andrei Ilyanov said to us, I said, well, but I knew they would. And sure enough they did. They came on the next plane straight away and were duly upset. But the point is, they presented to the Russian Academy of Sciences this model of radiative equilibrium at every level of the atmosphere. And in the break, some of us said to these guys, look, this is nonsense. You know it's nonsense. And they go, because you can have changes of state, everything. The photons aren't like conserved, they disappear, you know. And this guy said to us, he said, oh yeah, but this is what we do in schools. And then he said, well, it'll do for the Russian Academy of Sciences. And we said, what? It will do for the Russian Academy of Sciences. He said, yes. Then he stopped talking to us. But it's nonsense, right? That is the point I'm making. Now, there is, though, and the reason why it's nonsense is shown quite easily by what I said. What does happen, and this is a fair argument, we go to the next slide. Well, that's the same slide, really. The next one, this forwards. That one, yes. Now, you don't need to stand there anymore. You can if you like. No, okay. Thank you very much. Quick round of applause. The model did very well there. Okay. What does actually happen, and Richard Lindzen, who's like a lukewarmist, I would say. I mean, partly because, you know, better be lukewarm because if you're completely cold, you get no funding whatsoever, right? So he's a sort of, he's a good guy. When you go up in the atmosphere, you will get cooling, okay? And that is because under standard thermodynamics, a particle of gas expands as it goes up because the pressure is lower, it does work, and therefore, when it does the work, it uses up internal energy to do the work against the atmosphere. Or, another way of looking at it is, if you throw, if a molecule goes up and down again, oops, it's at the top of that flight, under gravity, it had no vertical speed. In other words, its scalar speed was lower. Okay, so that's why under gravity, higher up, you know, temperatures are lower. It's just exactly the same mathematically as the box doing work. All right. So you go up in the atmosphere, temperature goes down. Fair enough. Now, the real thing about what they call as greenhouse gases is that any radiation you put into, if you shine an infrared upwards, it gets absorbed actually. And any infrared, leaving aside what actually happens to it, it'll be absorbed within 25 metres. That's the end of it. It disappears. And those new levels, which are actually at a lower temperature than where we are now, will also radiate or turn that heat into water vapour or something. But it will get colder. Now, if you add more carbon dioxide or water vapour, which is also a infrared absorber and emitter, then the level at which, I can point there, but why don't I find my red spot? Hang on. Hold on. Right. Okay. So. You see, radiation here can only go up that much, and here this much. But at the top, where there's less and less infrared absorber above it, less water vapour and less carbon dioxide, radiation can escape completely. Okay? So they say, all right, more CO2, the physical level at which this radiation can escape goes up. It's a good argument. Okay? That means, though, that the top level of the atmosphere where stuff can escape is higher, physically higher. So you've got further to go down to get to the ground. Therefore, the temperature at the ground has got to be higher because the radiative level at the top is higher. Okay? So that makes warming. Right? Now that is a good argument, and that is the one they put. But see, it's difficult to explain this to children, so I don't want it. All Russian Academy of Sciences, you're apparently children, so you don't want it. But this is the one they actually use if they have a proper discussion. Okay. However, why doesn't this happen? Why don't we have lots of warming with CO2? Two things. One is that we've got feedbacks here. All the plants out of the window, they are transpiring all the time. If you add carbon dioxide, they grow faster. If they're growing, they're bringing in more water into them, and they're transpiring more, and that transpiration is a cooling process. So this also means the extra growth from the CO2 means cooling. So with the right figures, it's very easy. You can say, oh, well, it's trying to go up, but actually there's the extra cooling because of transpiration or refrigeration effect, and it goes down. So that end is nailed, so you're going to have a sort of curved lapse rate. The other thing is, there's a big problem with this upper level, right? And we go to the next slide. Right. If you add a infrared radiator to the upper level, what happens is you've got day and night changes. You see, standard meteorology doesn't like, dynamic systems. They all assume it's all averaged and flat. Okay. But the range of temperature changes in the 24-hour period will be bigger if there is more greenhouse gases up there. Okay. So the range of, this is now a temperature graph, fluctuation goes up. Well, if you've got an average, it's got a certain fourth power for radiation. If you've got a range, the radiation is the fourth power of this plus the fourth power of that divided by 2. If you've got a bigger range, it's the fourth power of this plus the fourth power of that divided by 2. Now the average of the fourth powers is much bigger than the fourth power of the average. Like 1 plus 2 plus 3, 2 is an average, right? 2 to the fourth is 16. 1 to the fourth plus 3 to the fourth, I think you find, is 82. And 82 divided by 2 is 41, which is much bigger, you see? So the range goes up, and therefore the radiation from the upper level of the atmosphere goes up. Now, their theory was, extra CO2, extra warming, you've got to have a warm spot above the equator, which will happen after 10 years, right, because of extra CO2. My theory says, oh, well, it's cooling. It could be a cold spot. Now let's go on to the next graph. This is their theory. There should be a warm spot above the equator, which happened i.e. compared with, it was 2010 compared with 2000 or something like that. What was observed was a gold swap. So you should applaud at this one. So, their own theory in dynamical terms fails every test. Now, I put this to Richard Lindzen because he's a lukewarmist. And he said, and this was about 5 years ago, he said, oh, Piers, yeah, the data must be wrong. The measurements must be wrong because whatever, he's got to be at least a lukewarmist to get funding anyway. So, you know, he's kind of wedded to that must be true and this is an accident. However, nobody has come back in the last 5 years to say those measurements are wrong. So I would say completely categorically the CO2 theory is wrong at every level. Thank you. More questions?
Are there any other speakers actually?
Sorry. Yeah.
That's all right. Who would like to be quizzed? I mean, we've got Don here.
We could have a last question if you want, and then another speaker, because I think...
Yeah, one last question.
Yeah, yeah. Okay.
Thank you. I have a lot of questions today.
Well, compact them into one then.
I'm going to try. Is it your contention then that essentially CO2 is a bit of a distraction? I remember you speaking...
It's total distraction, it's completely false. CO2 is the gas of life and we want more of it, not less. You should applaud that as well.
Is the motivation behind that distraction... What, in your opinion, is the motivation behind that distraction?
It's political.
Elaborate.
Okay, in 10 seconds, alright, 20 seconds. 2004 Global Oil Summit, I was invited to speak at Houston, Texas, the Global Oil Summit. Go there, about 100 people. I thought, that's not very many for a Global Oil Summit, and I realised who they were. There was less than 100 actually, more like 50. They were the heads of all the oil companies. Andrei Leonov, the one I mentioned that I saw in Moscow later, was there, Putin's advisor and so on. I gave this talk and said, look, it's the sun what does it, right? Now, I wasn't sure why I was even there, you know, because oil companies, what do they want to hear from me, right? Then, I'm just finishing the stage and this guy walks up to me, he says, oh, Mr. Corbyn, I just want to show you that we're onto this case already. And he flicked through this wad of papers and there was graphs in it of the sun doing this and that, and it was similar to my sort of graphs, you know. So I said to him, oh yeah, well, okay, you know already, what have you got me here for? And he said, oh well, we wanted to know from a real scientist practicing in the field, doing forecasting, that we're on the right track. We are on the right track. That was his phrase. He wanted to know, are we on the right track? I said, well, that's nice, thank you. And who are you then? I said. He said, oh, I'm retiring at this meeting, but I, up to this point, am the chief executive of ExxonMobil. Okay. So, later that year, friends of mine said, Piers, why didn't you ask those bastards for money? I said, look, I don't want to get mixed up with oil companies. I mean, they can buy forecasts, but, you know, it's just... So we said, what we do, we'd ask the United Nations for money and the oil companies for money. So my friends who were insiders, they went to the oil company and said, well, you like what Mr. Corbyn said, what about funding it? And they said, oh, no. We like what he said, but we do not want to upset the green lobby. Okay. And you see what they do. They like being attacked by the green lobby as the enemy of everything, but they're not. They're close friends of the green lobby. And if you read their websites, they say we support action against carbon dioxide so long as there's a uniform price for carbon across the board. Which means when a farmer is paid to burn food, he's got to be paid enough, i.e. more, than he is going to be paid by someone who wants to make it into a maize stew or whatever you do with maize, right? So, the oil companies then maintain oil price. So basically they double the profits and 98% of world energy in order to give away 2% to morons and wind farms and things like that. It's a no-brainer, a complete no-brainer. Thank you.
I think there's a cultural aspect to it.
There's a cultural aspect too, I'm sure.
Yeah. Have you noticed that there's always a doomsday scenario?
Right. Yes.
There's always a fear to play on, and when there's money in it, of course, that's even better.
because when in the 60s I remember there was an ice age.
No, it was. The Ice Age was coming, yes.
And then when that fizzled out, then we're going to be hit by an asteroid. And now we're all going to die from heat stroke.
Or we're going to be hit by the electric universe.
Hopefully.
Okay, perhaps I better end there.
Thank you. Yeah.
Are there any other speakers from Bath who want to be quizzed in the room?
And we'll leave.